Hey there, CJ Math students, and welcome to Unit 6, Inequalities. The beautiful news about inequalities is that they follow the kind of same pattern as solving equations, except that we have an inequality sign instead of an equal sign. So in essence then, inequalities are going to have multiple solutions, whereas equations, for the most part, had one solution. We had some special cases where we solved for no solutions and infinite solutions, right? But for the main purpose of inequalities, they're asking you, so I can go up to at most this amount, but I don't have to go all the way to 140. So like, what values can I do that include anything up to 140? Or I can have at the very least 120. What values can I have greater than that? So let's take a look at the difference between these two. Now remember that you always eat the bigger, so this is the greater than sign, and this is the less than sign. Greater than, less than, and then if I include a line underneath it that's greater than or equal to, less than or equal to, that should all be familiar. So on your first question in BuzzMath, they just ask you to compare. So 5 is less than 10, right? 5 plus 2, which is 7, 10 plus 2 is 12. Again, it's still less than, and then 5 minus 1, which is 4, and 10 minus 1, which is 9, it's still less than. So no matter what I do to those numbers, if I add the same number or subtract the same number, the inequality is not going to change. So when you add the same number on both sides of an inequality, it's always true. When you subtract the same number from both sides, the inequality is false. No, it's actually true. So read this statement carefully. Yours might be worded differently. Yours might say, when you add or subtract, the statement is always true, then that would be a true statement. All right, so here's the difference between an equation and inequality. Here, we know the answer to be 8, right? X equals 8. You drag this dot here to 8, and that would be your answer, right? The difference on an inequality is that X can be greater than 8. So you put an open circle on 8, meaning I can't necessarily include the number 8. I can include 8.000000001, right? I could make that go on for a really long time and just put a 1 at the end of it. And then every number above it. This is saying I have some value that I want. I just know that I want my expression over here to be greater than 10. What's the very first value I can have? And 8 plus 2 is 10. So that equals 10. So that's why I put an open circle on 8. If I wanted to include 8, if it was something like x plus 2 is less than or greater than or equal to 10, then I would put a closed circle on 8 saying, hey, I can include 8 as part of my solution. But this makes sense, right? 9 plus 2 is going to be greater than 10. 10 plus 2 would be greater than 10. 11 plus 2 would be greater than 10. All these numbers, all the way to infinity, added to 2 will be greater than 10. Right? Which values make the inequality apply? X plus 3 is greater than 8. So if I solve this, right, it's the same way you solve just a one step, right? X is greater than 5, right? So anything bigger than 5 makes this true. So 8, I don't know why they put on 8 there twice, but all those other ones don't make it true. For this one, again, same way, you just add -5 to both sides, and you get 10, right? X is greater than or equal to 10. Now, if I wanted to graph this, you always put a 0 at the very least, and you say, okay, here's 10 right here. You put a closed circle, because you want to include 10, right? You can be equal to 15, right? Because 10 plus 5 is equal to 15, and then I can include every number that is also greater than 15 all the way to infinity. So you draw like an arrow for the rest of the number line all the way off to the side. So like I could include 11 plus 5 is greater than or equal to 15. I could do 12 plus 5 is greater than or equal to 15, right? Just think about this scenario here. Like at the very least you want 15 of something, right? But you can go more than that. So like you have some value that you don't know, but you're going to add it to 5, and you want more than equal to or more than 15. All right. Here, if I wanted to graph the solution quickly, you'd solve it, right? Adding -6 to both sides, you get x is greater than or equal to 7, right? So I'm going to rewrite it here. You'd have a closed circle on 7, and then it would be pointing to the right because you want every number bigger than 7. because when you add 7 plus 6, you get something that's greater than or equal to 13. Here's a kind of a shortcut here. You want to be able to go in the direction the inequality signs point. So if I have this or this, you're going to have an open circle to the right or a closed circle to the right. And if I have this or this, you're going to have an open circle to the left or a closed circle to the left. Now there's such thing as what I call a rewrite flip, and pay attention because this is the only kind of confusing thing about inequalities. Everything else is just fine. If the variable is on the right hand side, we flip the inequality at the end. So if the variable is on the right, we flip the inequality. And why do we do that? We do it because when we're graphing, usually we like to go in the direction that this inequality sign points, right? That would be the easiest way to determine it, right? Let's solve this and let's not flip it and see what happens, right? So here I would say, all right, I need to do plus 5 to both sides, and I get something that looks like this. X is greater than or equal to 12, right? Now some of you would say, okay, if I wanted to graph this, I'd go to, all right, there's my 0, here's my 12. I'd have a closed circle, right? Because I know I have to include 12 in my solution. And you say, okay, so I go this way, right? But what is this saying? This is saying everything less than 12 should be part of the solution. But if you read this, you have to read this backwards, right? X has to be greater than or equal to 12. So you've messed up, right, in graphing that. You have to actually graph it like this. So there's your 12 and a closed circle, pointed to the right. And so that's why when the variable is on the right-hand side, we flip it. Notice how it gets flipped, and this becomes X is flip the inequality sign, greater than or equal to 12. 12, okay? That's kind of confusing. We'll be going over that a lot in this unit. That's one of the times you'll flip the inequality sign. That's the end of part 1.